Now see next question 15. Express minus I cap minus 3j cap plus 4k cap as the linear combination of the vectors 2i plus j minus 4k, 2i minus j plus 3k and 3i plus j minus 2k. So we have to express this vector in the linear combination of these three vectors. So we have to denote the given vectors as, so in solution we write this first vector which we have to express in linear combination. We consider as p bar equals to minus I minus 3j plus 4k, and this first vector as a bar equals to 2i plus j minus 4k, b bar equals to 2i minus j plus 3k, c bar equals to this last vector 3i plus j minus 2k. Now we have to express this vector p bar or vector p in the linear combination of vector a, b, c. That means there exist three scalars x, y, z such that p bar is equal to x a bar plus y b bar plus z c bar. That means we have to find the value of these scalars x, y, z. So first we substitute the value of vector p, vector a, vector b, vector c, and by equality of vectors we write this in the form of equations. So substitute the value of vector p. Vector p is minus I cap minus 3j cap plus 4k cap is equal to x into a bar. So x into a bar is here 2i plus j minus 4k plus y into b bar is 2i minus j plus 3k plus z into vector c bar is 3i plus j minus 2k. So we have to multiply each equation. So we multiply this bracket by x, second bracket by y, and this third bracket by z. So we write here minus I minus 3j plus 4k is equal to multiply by x. We write here 2xi plus xj minus 4xk. So multiply second by y, we get here 2yi minus yj and 3 into y, that is 3yk plus 3yk plus. Now multiply by z, so we get here 3zi plus zj plus minus 2zk minus 2zk. Now observe unit vector I cap. That means we have to take unit vector I cap common. So in first bracket we write here 2x plus 2y plus 3z into I cap. In same way, observe the j cap vectors, j vectors. So j unit vector taking common, we write in bracket x minus y plus z, x minus y plus z, j cap. We take j cap common. Similarly, plus here we take k cap common. So in bracket we write minus 4x plus 3y minus 2z into k cap. Now by equality of vectors, here we equate coefficient of I with coefficient of I. So by equality of vector, here coefficient of I is minus 1 here coefficient of I is this bracket. So we write here 2x plus 2y plus 3z is equals to -1. Denote this as equation number 1. Now equate coefficient of j with coefficient of j. So we write here x minus y plus z is equals to, here coefficient of j is -3. So denote this as equation number 2. Now third, minus 4x plus 3y minus 2z is equals to, here coefficient of k is 4 and in RHS coefficient of k is this bracket. So this is equation number 3. Now we have to find the value of variable x, y, z. You can solve this by Cramer's rule or by using the matrix method. So which is convenient for you, you can use for finding the value of variable x. Now we solve this problem by matrix method. So first we write these equations in matrix form. So we write in first column coefficient of x, in second column coefficient of y, and in third column coefficient of z, and in RHS constant that we already studied in chapter matrix. So we reduce this matrix into upper triangular matrix or lower triangular matrix. So we write here in place of 1 we require 0, or in place of 2 we require 0. So we write here instead of 1 we require 0. So we write here 2 times R2 minus R1. Instead of this minus 4 we require 0. So we write here R3 plus 2 into R1. So these two elementary transformations we use for reducing it. So keep first row as it is, 2, 2, 3. Now R2 to second row we have to multiply by 2 and subtract element of first row. So 2 into 1 is 2, 2 minus 2, 0. 2 into R2, R2 is minus 1, so minus 1 into 2 is minus 2, minus 2, so we get here minus 4. R2 is 1, 1 into 2, 2, 2 minus 3, 2 minus 3 we get minus 1. Here R3 is minus 4, R1 is 2, so first multiply this first row by 2, 2 into 2, 4, so minus 4 plus 4 we get 0. R3 is 3, 3 plus 2 into 2, 4, 3 plus 4, 7. Then R3 is minus 2, 3 into 2, 6, minus 2 plus 6, which we get 4. X, Y, Z is equals to. Now keep the first row element, that is minus 1, as it is. So we have to multiply second row by 2. So minus 3 into 2 we get minus 6, minus minus plus 1. So we get here minus 6 plus 1, which is minus 5. R2 minus R1, then we have to apply R3 plus 2 times R1. R3 is 4, so 4 minus 2, because 2 into minus 1 is minus 2, 4 minus 2, we get 2. Now in place of 4 we reduce it to 0. So we use here R3 plus 4 times R2. So keep first row element, second row element as it is, 2, 2, 3, 0, minus 4, minus 1. Here R3 is 0, R2 is 0. So 0 plus 0 we get 0. R3 is 7, R2 is minus 4. So here 4 4s are 16. So 7 minus 16. So we get here minus 9. R3 is 4. 4 minus 4 we get here 0. Write first row element, second row element as it is. Now we have to apply this formula. R3 is 2. R3 is 2 plus 4 times R2. R2 is minus 5. So here we get 4 5s are 20, so minus 20 plus 2 we get minus 18. Now we can reduce this, so we write again in the form of linear equation. So write first equation as 2x plus 2y plus 3z is equals to minus 1. Second equation as 0 into x, so we skip the variable x term. Here minus 4y minus z is equals to minus 5. This is second equation. And third equation is, here coefficient of x is 0, coefficient of z is 0, so we write here minus 9y is equals to minus 18. So first we find the value of y. From this we get y is equals to plus 2. So we denote this equation separately here. So this equation we consider as equation first, this second equation we consider as equation number second, and this value of z, this is equation number third. Now we substitute this y equals to 2 in equation second. Therefore minus 4 into 2 minus z is equals to minus 5. Therefore minus 8 minus z is equals to minus 5. Therefore from this minus z is equals to, after transferring this 8 to right hand side, we get 8 minus 5 which is 3. So minus z equals to 3, that means z is equals to minus 3. So in this way we can find value of y, value of z. Now we have to find the value of x. So substitute the value of y and value of z in equation number 1. Therefore from equation 1 substitute this value. So we get 2x plus 2 into 2 plus 3 into minus 3, because z is minus 3 is equals to minus 1. So 2x plus 4 minus 9 is equals to minus 1. 2x. Now 4 minus 9 which is minus 5. After transferring this minus 5 to right hand side, we get plus 5 minus 1 which is equals to 4. That means twice x is equals to 4. X is equals to 2. So in this way we get value of variable x, value of variable y, value of variable z, that is the value of scalars x, y, z. So we express the vector phi bar. P bar is equals to x a bar plus y b bar plus z c bar as, substitute the value of x, y, z. So we write here 2a bar plus value of y is 2, 2b bar, value of z is minus 3. So we write here minus 3c bar. That means the given vector can be expressed in the linear combination of the vector a, b, c. So in this way you can find the value of variable x by using matrix method, or by using Cramer's rule, or by reducing the variables, and by solving the simultaneous equations you get the value of variable x, y, z. You are free to solve the equations and find the value of variable by any method, but we have to show only that given vector can be expressed in the linear combination. Students who are interested to solve this problem by using the Cramer's rule can be solved by using Cramer's rule and check their answer by this slideshow. So see, you can write the linear combination as we solve this example. So by equality of vectors we write up to equations as it is that we see in first method, but here we solve the linear equations by using Cramer's rules only. So you have to write the determinant D, then value of determinant dx, value of determinant dy, and value of determinant dx. Then you get value of variable x, value of variable y, and value of variable z. So you can check if you solve this problem yourself by using Cramer's rule. So in this way we complete the exercise 5.1. So if you not see the previous parts, so see the previous parts and you will get clear idea about the vectors